All right, everyone, get ready, because today we're diving deep into software migration. Specifically, we're tackling a question we got about upgrading systems, manual or tools. We got an interesting document from Great Migrations comparing these approaches, and I think you'll find it pretty eye-opening.
It is fascinating, isn't it, the way this document breaks down the complexities of choosing a migration strategy, especially when considering a great migration. Like, do you go for a complete rewrite, or do you use a tool to help you?
Okay, so let's start with the basics. Why migrate software at all? Isn't there that saying, like, if it's not broken, don't fix it? Why mess with something that's working?
Well, imagine running a business today but using only a rotary phone. Sure, it still makes calls, but think of all the things you're missing out on compared to a smartphone. Technology's always changing. Languages, libraries, platforms, they all evolve. So clinging to outdated software, that means you're missing out on performance boosts, new features, and the support of a thriving community of developers.
So it's not just about chasing the latest trends. There's a real business case for migrations.
Yeah. Exactly. Migrating unlocks new potential for your software to grow with your business, to adapt. Migrations are about strategically positioning your software for the future.
That makes sense. But this document points out some pretty big assumptions for any migration project, like architectural overhauls, maintaining that old code, and making sure nothing breaks during the transition. It's a lot.
Oh, it definitely is. Migrations are complex. There's no way around that. The document lays out 6 key assumptions, and I think they really drive home the complexity. First, you got to have a really solid reason for migrating, a clear business case. Then there's likely going to be architectural improvements needed as part of the move. And you can't just ignore that old code. Active maintenance of the legacy codebase is key, breaking existing functionality. Not an option. The new system has to be easier to maintain. That's the goal. And lastly, all of this has to happen efficiently and cause minimal disruption to everything else.
Hearing all of that makes me want to just hit the easy button and go for a fresh start, like do a complete manual rewrite. Just wipe the slate clean, out with the old, in with the new.
Oh, I get that. That fresh start is tempting. But the document brings up a big challenge with those manual rewrites. You're essentially relying on understanding the old system, the legacy system, from the outside in, knowing what it does without truly getting how it works on the inside. Imagine trying to rebuild an entire car just by looking at it. You might get the basic shape, but good luck with the engine and all the little details.
Oh, yeah, that's a great analogy. You'd miss all those tiny bits and connections that make the whole thing work.
And in a code base, especially a large one, those details, they can get super complex, especially if it's code that's been around for years and years. Plus, even subtle differences between those platforms can make figuring out that old code even harder.
Okay, so what about these low-yield translation tools? The document mentions those. Could they help with manual rewrites?
Sometimes they are used, yeah. But think of it like using Google Translate for a super complex legal document. You might get a very rough draft, but you wouldn't actually use it without an expert reviewing every single word. These tools often leave you with a ton of code that still needs manual work, which kind of defeats the purpose.
Okay, this makes me think about the cost of all of this. How do you even start to estimate the cost of a rewrite? It's like trying to budget for a trip to, I don't know, a foreign country where you don't know anything about the currency.
Yeah, it's really difficult. The document does actually mention a formula. Migration effort, XY. X is a percentage of the original effort, Y, the development effort. But even the document says those numbers are hard to get accurately.
So what does determine the real cost?
It goes way beyond that initial development cost. Think about things like your organization's maturity, the development approach you're using, the overall scope, and how long the project will take. It's a multifaceted thing.
This is starting to sound about as fun as doing my taxes by hand. Technically possible, but, tedious.
And that kind of leads us to a classic debate. Waterfall versus incremental migration.
Ah, waterfall. That's where you do everything in huge sequential chunks, right? It feels like the opposite of agile.
And for migrations, waterfall is usually a recipe for disaster. Think, long delays, high risk of things changing halfway through. Imagine finally finishing this massive migration only to realize what you needed has changed completely.
Oof, that's a nightmare. What's the alternative?
Incremental migration. This is where you build the new system piece by piece, in stages, and run it alongside the old system for a while. It's more gradual and much more adaptable to changes.
That does sound more manageable. But I bet there are challenges there too, right?
Of course. Integrating the old and new systems, that gets complex. Users might have to deal with 2 systems for a bit.
Yeah.
And managing that in the runtime environment is no picnic.
All right, I'm starting to see why migrations are such a headache for people. Let's talk about the tool-assisted approach, specifically great migrations. What makes it stand out?
When this document says tool-assisted, it means a high-yield approach like Great Migrations. It's heavily iterative and relies on specialized tools for automated refactoring. It's not just about blindly running your code through a converter and hoping for the best.
So you're working with the tools, not just letting them do everything.
Yes, the Great Migrations methodology, they call it GMM, has this really interesting translation tuning phase. You literally teach the translator how to handle the quirks in your code and the specific results you want.
That's pretty cool, like creating a custom translator just for your system. What about that fit and finish plan I saw mentioned?
That's all about balancing automation with manual work. It acknowledges that while automation is great for the heavy lifting, some fine-tuning and customization are probably going to be needed, to make sure that new code base truly meets your production standards.
Okay, I'm definitely liking this idea more and more. Now I want to know, how do manual and tool-assisted approaches compare across like the entire software development lifecycle?
Great question. Let's start with setting the scope. Both methods require really careful planning to, figure out what's actually moving and how to minimize disruption. But the GMM has a speed advantage here because the main effort happens up front, tuning the translator. You can potentially even finish that before making the final switch to the new platform.
So you can avoid that disruptive code freeze? Legacy development can continue while the tuning is happening.
Exactly. It keeps things moving smoothly. Now, when it comes to gathering requirements, that can be a real beast, especially for large legacy systems.
I bet. Figuring out all the little details of what the system does, that must be so tough.
It really is. The document actually has this table comparing different sources for gathering those requirements. It rates the effectiveness of using users, developers' existing documents, and the legacy source code itself for figuring out both the functional and technical needs.
So what stands out in that table?
Well, what's interesting is that the GMM actually leverages the legacy source code itself as a detailed specification. It's like having a blueprint of the existing system.
Smart, using what you already have. So what about the analysis and design phases?
Both methods involve digging into those requirements and finding solutions for things like language incompatibilities, API replacements and other technical hurdles. But the GMM streamlines things. A lot of these problems basically get addressed during that translation tuning phase we talked about.
So each developer isn't solving these problems on their own. You're teaching the translator to handle them. That's brilliant.
Right. And they use what's called translation configuration, which is basically a set of instructions written in XML files. These get refined through that iterative tuning process to make sure the translator gives you the exact code you need.
Clever. Okay, what about the actual construction phase? The coding part.
Both approaches might still involve a good bit of coding, especially if you're adding new architectural stuff. But the GMM shines here. It automates the majority of the code conversion for, the core business logic. We're talking potentially translating hundreds of thousands of lines of code in just minutes, all while maintaining quality and consistency.
Wow. Okay, what about testing?
The testing activities themselves are pretty similar between approaches. But with the GMM, you can start runtime testing much earlier because you can generate code faster, catch issues early on. The document also talks about side-by-side testing.
Side-by-side testing, is that like running both systems at the same time and comparing them?
Especially useful for large systems where you might not have great regression testing. You basically run both systems side by side, compare outputs, behaviors, make sure everything matches up. It helps you catch any weird discrepancies.
Okay, that makes a lot of sense. So what about that cutover phase, when you finally switch to the new system?
With a manual migration, cutover is often a long and painful process. Lots of new code to refine, build, test. And usually that means keeping the old system running at the same time, which can be a logistical nightmare. But with the GMM, cutover happens when your team feels confident about the translated code. And because of that tuning process we've been talking about, the code should be very close to production ready.
So the GNM basically makes for a much faster and less disruptive transition. You do the hard work up front so the actual switch is smoother.
Exactly. Less downtime, less risk. Now, let's talk about the last stages, deployment and maintenance.
What happens there? Any big differences?
Those phases are pretty similar for both. But the GMM has a hidden advantage. Since the new code comes from the old code, it's more familiar to your developers. This makes the transition easier, and they can adapt to the new platform faster.
It's like they already know the logic, just have to learn the new language.
Yeah, it really does smooth things out. Okay, we've covered a lot here. We've seen why migrating is so essential for your software to stay relevant, but also how complex it can be. We've talked about the ups and downs of manual rewrites, the problems with waterfall, and the advantages of doing things incrementally. And of course, we've delved into the Great Migrations methodology with its focus on automated refactoring, translation tuning, and a more streamlined cutover. But before we move on, there's this myth-busting section in the document that I want to talk about. It addresses some really common misconceptions about using translation tools. Frankly, these myths are surprisingly persistent, even today. They really are. And the document does a great job of debunking them one by one. For example, one myth is that you absolutely have ET to rewrite everything from scratch.
Right, like tools just aren't up to the task. But you're saying there's another way.
The GMM allows for a hybrid approach. You can choose to rewrite specific parts as needed, and the translator can even be configured to integrate that handwritten code. It's not all or nothing.
Ah, so you get the best of both worlds. Flexibility. What about that myth, the one about the code produced by translators being junk?
Oh yeah, the garbage in, garbage out fear. But remember that tuning process we talked about. With the GMM, you refine things constantly. If the translator spits out code that's not up to par, you identify the issue, tweak the configuration, and regenerate it. It's about continuous improvement.
So you're actively shaping the results, not just trusting the tool blindly. What other myths does the document tackle?
Well, there's the one that claims some tasks are just too complex for a machine to handle. The only a human can do it argument.
A human touch. But the document challenges that, right?
Yes. It argues that many of those tasks can be broken down into steps that a translator can learn. It's about recognizing the power of these modern tools, especially with things like semantic analysis.
So it's not replacing humans, it's about freeing them up from those tedious, time-consuming tasks. What about the myth that legacy code is basically worthless because it was built for a different platform?
That's a big one. But the document emphasizes that legacy code is a gold mine. The language APIs might be old, but the core business logic is often still relevant.
It's like translating a book. The story's the same, even if the words are different.
And the document even mentions that if any details are truly missing for the new platform, you could provide that input to the translator. It's about bridging that gap, not throwing away valuable knowledge.
I'm learning so much. It seems these myths come from underestimating what modern translation tools can do.
For sure. There's one final myth, and it's basically, it can't be done. That pessimism that surrounds migrations, especially complex ones.
So how does the document counter that?
It showcases the power of modern tools like the ones used in the GMM. It highlights their ability to handle even really complex migrations, and that's based on years and years of research in computer language translation. It's a reminder that while challenging, migrations are possible, especially with the right tools and approaches.
That myth-busting section is so important. It's like, it's time to let go of those old ideas and embrace the possibilities.
Absolutely. We've come a long way from those old, clunky translators of the past. Today's tools, they're sophisticated, they're customizable, and they can handle the most complex migrations. And that makes software modernization so much more achievable.
This has been amazing. We've learned about why migrating your software is so important to stay relevant, but also just how complex it can be. We've talked about the pros and cons of manual rewrites, the problems with the waterfall method, and the advantages of an incremental approach. And of course, we've dove deep into the Great Migrations methodology with its automated refactoring, translation tuning, and streamlined cutover process, but I feel like we're just getting started.
And that's what's so great about these deep dives. They spark curiosity and challenge our assumptions, and they open up new avenues to explore. And speaking of exploring, this document has got me thinking about all the factors that go into choosing the right migration strategy. It goes beyond just the technical stuff. It's about understanding your organization, its resources, its goals. Right. It's like choosing a vehicle for a road trip. You wouldn't use a tiny sports car to move your whole family across the country.
Exactly. Just like planning a road trip, planning a software migration means thinking about your destination, what you'll encounter along the way, and the resources you have available.
So what are some questions organizations should be asking themselves as they plan a migration strategy?
Well, first of all, you need to understand how big and how complex your current system is. How big is the code base? How intertwined are all the pieces? How well documented is everything? Those factors will have a huge impact on the feasibility and cost of different approaches. It's like checking out the size and condition of your car before deciding if you should repair it, get a new one, or maybe switch to a completely different type of vehicle altogether.
And just like with cars, there are trade-offs. A manual rewrite might give you total control and flexibility, but it's going to take a lot of time and resources. A tool-assisted approach, like Great Migrations, can speed things up and reduce that manual work, but you need to invest in tuning that translator and understanding what it can do.
So it's about finding the right balance. Control, efficiency, cost. What else comes into play?
Your team's skills and experience. Do they know both the old and new platforms really well? Are they comfortable using these automated tools? Or are they more used to doing everything manually? The answers to those questions are going to help you decide which approach is going to work best. A really skilled team might be fine doing a manual rewrite, but a team that's not as familiar with the new platform might need the structure and guidance of a tool-assisted method.
It's about playing to your team's strengths and knowing their weaknesses. What about time constraints? How does that affect things?
Time is a big factor in migrations. Businesses need to minimize downtime, keep up with their competitors, and meet those deadlines. If speed is the priority, a tool-assisted approach, especially with an incremental strategy, can be a lifesaver.
It's like choosing between a scenic route and a highway. The scenic route's beautiful, but it takes longer. The highway's faster, even if it's not as pretty.
Sometimes you just got to prioritize getting there quickly, especially when deadlines are looming.
So finding that balance again, thoroughness versus speed. What about risk tolerance? How does that fit in?
Risk tolerance is super important, especially for mission-critical systems. Manual rewrites can be risky, even with all the potential for innovation. You're more likely to make mistakes or overlook dependencies. Tool-assisted approaches, especially those that focus on testing and iterative tuning, can help mitigate those risks by creating a more structured and repeatable process. Organizations need to consider their own risk tolerance. How critical are the systems we're migrating? What could happen if there are delays or errors? Those are the questions to ask.
It's about being honest with yourself about what your organization can handle and where your limits are. We've talked about the technical stuff, the different methods, and how to choose the right one. But there's something we can't forget about the human side of these projects. Migrations can be stressful, disruptive, emotional, even for the people involved.
You're so right. Software migration is about people, not just lines of code. It's about helping developers adjust to new technologies and new ways of thinking, managing expectations, communicating clearly, making sure everyone is working together. A software migration depends on good communication, strong leadership, and a supportive team.
So any practical tips for managing the human side of a migration?
Involve your development team from the very beginning. Get their input, hear their concerns, train them, make sure they understand why you're doing this, what the benefits will be, and how their roles might change. The more involved your team is, the more likely they are to embrace the process. And set up clear communication channels, have regular meetings, address roadblocks, celebrate successes, encourage your team to share their challenges and learn from each other. And one more thing, invest in training your team. Give them opportunities to learn new technologies and grow their skills.
This has been fantastic. We've talked about so much: the technical challenges of migration, the human element, the importance of choosing the right approach. But I feel like there's so much more to explore.
There is. And I think it's important to remember that software migration isn't just about replacing old code. It's about helping businesses evolve and adapt in this rapidly changing digital world. Software migration can be a catalyst for positive change and innovation.
It's like, how can these migrations actually drive innovation within a company?
Well, first, think about modernizing your tech stack. Migrations allow you to take advantage of all the latest advancements: cloud computing, AI, data analytics, all that cutting-edge stuff.
It's like trading in your old clunker for a brand new car with all the latest features, right? Makes the whole journey so much better.
Exactly. And then there's the breaking down of silos. Migrations can help you integrate all those separate systems you have, create a more unified, streamlined digital ecosystem. Migrations can free up your IT resources, reduce those operational costs. That lets you focus on what really matters, like strategic initiatives and innovation. Migrations can actually help foster a culture of innovation. By embracing new technologies, adopting agile methods, and promoting collaboration, you create an environment where people are encouraged to experiment, learn, and adapt. Software migration, when done right, can be a powerful driver of change and innovation. It helps companies evolve and thrive in this constantly changing world.